everyone. My name is Sushil, and I'm part of business development here. People who have attended our previous webinars, Microtraining, etc., they might have heard me before. So I'm just going to quickly brief about the company, who we are, and what we do. This company, Julia Computing, is created by the Julia language creators. And I believe everybody can see my screen and hear me fine. If not, do let me know. Just ping in the chat box if you can. So the company, yeah. We're saying something, Sanjeev?
I said we can hear you.
Okay. So the company is founded by the Julia language creators and has a qualitative team, most of which are early Julia language contributors and part of the ecosystem. So the whole idea of having this company in place was to help Julia users across different domains. In order to do that, the company has come up with a set of products and other offerings. Julia Pro, which you see on the screen, first in the list is our distribution product. Comes with Atom-based Juno IDE, inbuilt profiler, compiler, debugger, etc. If you wish to try it out, you can visit the Julia Pro product page on juliacomputing.com. Download, install, and play with it. And need any help on the same, you can always reach out to juliapro@juliacomputing.com. Julia Team is our enterprise product. So this product makes sure that when it comes to making Julia work seamlessly behind your enterprise firewall, when it comes to overcoming the proxy server limitations, when it comes to capabilities like having a unified platform to get the features of searching documentation or codes, or having governance in place by getting the administrative part in place from a tool, assigning roles, scope, managing licenses to a certain extent, and managing your private packages. Such capabilities this product comes with. And Julia Run is an add-on product to Julia Team, which means it shares the same UI. It's part of the same console. And this product comes with capabilities on deployment and scaling. So when it comes to running your Julia application on a number of nodes on your HPC cluster, when it comes to having the flexibility of batch processing, when it comes to getting the features of auto scaling, single click deployment, parallelization, such stuff is what Julia Run is leveraged for. Julia Shore is our enterprise support and indemnification offering. So when it comes to an individual or a group within an enterprise, you need help with your ongoing Julia project, an ongoing support is what you're looking for. If you're looking for us to review your code and help you out, kind of jump starting your project or getting the expected results, troubleshooting, bug fixing, such capabilities are included in our Julia Shore offering. Pumas is our enterprise, pharmaceutical modeling and simulation platform. So, precisely if I talk about it, when it comes to getting a better substitute, of tools like NonMem, Phoenix, tools like Monolix, that's where Pumas, has been getting recognized, and it comes with the capabilities on PKPD modeling, QSP, PBPK, IBC, bioequivalence, and such stuff. So when it comes to knowing more about any of these products, or if you have any particular questions, you can always reach out to us, write to us at sales@juliacomputing.com. If you're interested, we can schedule a live product demonstration for you where we can showcase the product capabilities, answer any questions you might have, and that way you can figure out if it's the right fit for you or not. Apart from this, we do have consulting services and training offerings. When you visit juliacomputing.com, you would see a training tab on the homepage. There you will find all the information on our on-demand training or on-site training. At the same time, for any consulting engagement interest, you can always write to us at sales@juliacomputing.com. You can see a few, logos on my screen, which are our customers. So I always say this, that this is not all we have, but this is top of the list we have. So if there is a need, for let's say customer testimonial or references, we can offer that as well, for you to kind of give you the comfort before you make a decision to go ahead with our offering. That's pretty much it. I'm not going to take any long. With that, I'll request our presenter Daria to take it ahead. Thank you.
All right. Thanks, Sushil. That was a really nice introduction to the company. I'll add to that for people who are part of different kinds of domains, different kinds of backgrounds, I highly recommend looking at some of the case studies that we have on the website. There's some really interesting ones, and always spread across multiple domains. So be that through pharmaceuticals or machine learning, or just straight up heavy compute with GPUs and such. There's a lot of you know really cool case studies on the website as well. Um, Hi everyone, my name is Dheerja. I'm a data scientist at Julia Computing, and I also developed a lot of the Julia machine learning stack as a whole as well. Maybe some of you might have worked with Flux if you're used to working with some of the machine learning tools that we have, and Cygot and such. And that's some of the areas of work that I have contributed to. Before I start, I would really want to send across the message that at any point in time, feel free to shout, give me a shout, and either in the comments or directly, just unmute yourself and speak up, and that way we can have a more engaging, discourse. It's always more interesting when there's back and forth. Also, I really appreciate most of our kinds of micro trainings, as we like to call them, to be a bit more communicative. So maybe it helps both of us, right? So like if folks want to ask questions that are specific to their domains, for example, or something that directly pertains to their use case, I would be more than happy to answer those questions. Um, so we'll also have a little bit of time saved at the end for a bit of a Q&A. And even before that, as I said, feel free to shout, but we do have some time at the end as well. So with that housekeeping business out of the way, let's begin, shall we? All right, just to get an understanding, where do people basically stand? What kind of experience, um, experiences that people share with Julia, with machine learning, with Julia, etc. And like how productionizing, capabilities are interesting. And we'll probably talk a bit more about that later. But it'd be good to get an idea of about the backgrounds of the people that we have on call today. Feel free to just unmute yourself. All right. Maybe let's just get started and we'll see how it moves on. So we are going to be basically taking a very simple machine learning model, a simple neural network, a convolutional neural network, as a matter of fact. We'll train it on a very basic MNIST data set. Um, but a lot of this is just for more for demonstrative purposes, right? So like when we actually work with larger models, obviously the things change a little bit, but we really do appreciate when people want to talk about you know how do you productionize a very complicated model, and that can be through batch jobs, or what if you wanted very close and delivered to a large number of users. What if you want a UI to go along with it? Things of that nature. How do you handle completely unexpected circumstances? Those are the kinds of things that we'll walk through in this little demo here. um, Let me also start by talking about the Dash platform that we'll be using. And this is developed by the Plotly team. It's a very, really like a simple but very effective way of demonstrating machine learning as well as data science platforms. So people can use it in a more visual manner. Of course, we have our own version of that. So this is developed by the same team at Plotly, which is a straight up Julia interface to the entirety of the Dash ecosystem. And let me wrap some of the work that they've been doing. It's really easy to use. We'll see that in a minute. And what we will also walk through is how do we reason about running something like this. Say, especially if you have to give it to someone who has little or no data science experience, how difficult it is for them to like take over the task of, say I have a really well trained model, but now I need someone to productionize it, or send it across as a product or updates or however. Um, as I mentioned earlier, we will be using Flux, and we'll be taking a model that we train with Flux and putting it on a server, depending on what kinds of capabilities we're looking for, and we'll make sure to either have it served to a massive number of audience, or tuned for performance specific to some kinds of hardware, for example, GPU backed instances, or even, so this is a little bit out of scope, but even if you want to do batch jobs for large scale batch jobs, right? And for that, we will probably want to have our own subsystem where rather than having a UI, we would rather have something that gives us higher throughput and higher parallelization, etc. Right? But in the case where we want to make sure that we have a simple but effective model distributed to a large number of clients, we want to make sure that we can host it, and not only just host it, but also make sure that once it's running reliably. For that, the example that we're going with here is Heroku. Do folks have any experience with Heroku in the past? Right, folks want to use some of the Flux tools in physics-informed ML, SciML, and yep. All right. So Heroku is basically a service which allows you to create simple, and starting from simple but going to significantly more complex web-hosted services, right? And on top of that, all the compute that comes in comes through whatever code that we write. So in our case, what we want to do is we want to put a trained machine learning stack behind a web server on Heroku. So that way, all the hosting is taken care of by Heroku, and all we really have to do is maintain a very, very simple backend for us to maintain as we do with any other software development project. So I hope you can see my screen. I have made it so that as of right now, the only apps and information that you see is strictly non-private. But either way, it's so we can basically get a good idea of what we're dealing with. So this is the basic UI for Heroku. Obviously, so what you would want to do in here is go to some of their documentation. It's a very, very rich platform, and they have documentation about their CLI specifically, which is something that we'll be interested in, and so on and so forth. Right? We'll currently stick with the areas that pertain to us immediately. All right. Let me. So, do folks have any questions? I'll be happy to take any questions in the meantime as I get the link. Yep. We can definitely write custom data loaders. That's absolutely doable. For example, ImageNet and I think Coco also has a dataset loader. And if you want to write your custom ones, we definitely have utilities in Flux that allow you to write those very, very easily.
Sorry, quick question. Do you want us to create a Heroku account or not?
So yeah, absolutely. I would encourage you to create a Heroku account if you want to, play along with this. Like if you want to do it hands-on, that would be absolutely ideal. I would basically go from scratch where we actually to the point where we actually have a web server running on Heroku. On the other hand, I have a completely new instance of Heroku running in Shed, where I would discuss what it's doing and how we're going to be dealing with Heroku in Julia. So there's a question about accept ImageNet and Coco. Of course. So if you were to go to fluxml.ai, the documentation is right there. And what you want to look for is the data loader class that has all the information on how to create your own custom data loaders. All right, with that, let me share my screen here. So what we're going to be currently starting with is an completely empty, but also, this is just the same Git repository as I have posted in the chat. So let me post that again for anyone who missed that. And this contains some of the scripts that we would need to actually start up our Heroku instance. But before we do that, let me walk you through exactly what we have to do for our Dash app to work in the first place, right? All right. So this script is actually included in the same Git repository as I put up earlier. And the idea, this comes with a lot of literature about what is happening in every stage of the process. but I would like to quickly go through it so we have a good idea of what we're dealing with. One important thing to note here is that while working with Julia scripts, especially ones that we expect to productionize, it's highly important that we engulf everything in a single environment, in a single manifest. So what I would recommend folks is that when you're starting your Julia session, you activate a project, and in that project you keep a track of all the packages that you need. So in our case, we're going to be dealing with HTTP, dashboards, Flux, images, and BSON. Right. So this is the training script for our actual machine learning model. There's nothing too special about this specifically, in the sense that we are basically loading in the MNIST data set, making mini batches out of it. Here is our model, and we want to train it. Notice how that while training, we are using GPUs. So this is probably on high throughput cluster somewhere, or a machine learning system, dedicated system where we can train these large models. So of course, this is a fairly trivial task as it stands, but in general, so you can imagine training a huge transformer this way. With that, we simply train our models. One thing to note is that while training, we do make sure to also checkpoint our models at various stages. So be that while every time accuracy increases, or when it plateaus or something like that. Especially important when we want to take advantage of things like early stopping. Um, the idea is essentially that once the training loop is actually completed, we end up with a BSON file essentially. We use the binary BSON format to store all of our models and our parameters. The idea is that by the time that our training loop has ended, we end up with a BSON weights file, which we can actually port around to wherever we need to actually productionize our models at. So this is interesting also because it means that we're decoupling the role of a data scientist from that of a production engineer. This way, the person who is responsible for actually putting these servers up and responsible for maintaining them is is able to work independently of whatever models come through, because all they really care about are a couple of BSON files, as we'll see. So here in our actual script with the server, you would notice that we load the model that we saved earlier, and we load the weights as well. So the Git repo also has the pre-trained weights in there if you're interested, but that's a very easy model to train either way, but that's provided in case folks want to use exactly that model. And all we really have to worry about from the point of view of the productionizing system is that we have our model, we have the pre-trained model, and we know how to call all our inputs using that model. So the next part of it is really just the dash part, right? The Plotly dash part. And the interesting thing that we start with here is we make use of any external CSS and JS, style sheets and whatever helper functions that we need in case we want some special look and feel to our in our dashboards, right? So this is especially in case for when we're putting it out to a large audience where UI and UX is an important part. And outside of that, what you would notice is that everything in our actual production system looks very close to how it would in HTML. Now that can be both a good and a bad thing depending on who you ask. but it does mean that the barrier to entry for a complete newbie to Julia is reduced significantly because they can make use of a lot of the same semantics as they would in any other place. And notice also that there is no JavaScript involved. We basically end up with this Dash app that we call. This has information about all the kinds of favicons, where our assets lie, things of that nature. Um, and another interesting thing that is important as well is that notice how we don't really have to write any URI handlers. We could if we wanted to, but in the general case, uh, that's not a paradigm that's enforced in any way or form. Which also means that we have to handle information going back and forth, and we do that with the help of callbacks. So basically, what we do is we register callbacks that take that go from one value to the other that manipulate something, get the input value out in the form of generally a string, but Dash will try and convert it into the the data type that it thinks is the most relevant. But either way, we don't really have to think too much in terms of how to implement these things. You would notice that it's a fairly minimal interface. Another thing that's pretty cool and something that I really like to share with folks is that in all of this, we can use whatever facets of the GUI language that we want. These are just normal functions, which means that everything from performance optimizations to creature comforts and different kinds of just packages that people might be used to working with are available to us in an expressive form, which means that we're also using, say, things like images and Flux together inside a Dash model. All right, this was a little bit to do with, I don't want to delve too deep into, what the actual script is doing. Suffice to say that it wants to take an input value, which will be a URL in our case, where it would take an image, download that image, and then run it through a machine learning model and show us the output in sort of a bar graph to show where the inference lies. Do folks have questions at this stage? Seeing none. All right. So one interesting part of this is also that we now just want to run our app, and usually what we end up doing is we have to write a lot of boilerplate code to register where our models are run, what nodes, what ports are they run at, things of that nature. In our case, we just have to really worry about uh, the port, because that's important information that we have to give to Dash. But outside of that, there's most of the things will be handled for us. So let's just take a look at this thing called the proc file that Heroku expects us to write. So this is just a single file, and it has a basic, it gives a basic implementation of what it has to do to actually run the server. So all we have to say is call Julia with the project. As I mentioned earlier, it's important that we keep this project for reproducibility, which means that if we have, say, 1,000 nodes where we have to deploy this to make sure that it's available to everyone with the least amount of latency possible, right? In that case, we want to make sure that everything, including the binaries, the environments, everything is completely reproducible. Also automated, but that's a separate concern. to a certain degree. And what we would do is call it with this project, which gives us the project and the manifest. Call the utrain file, which contains our serve function. It has our callbacks. It has all the style information we need, and it has how to reason about the images and with Flux. Another important thing finally is the call to port. This is an environment variable that is available in Heroku at runtime. It provides the port that it will be run at. The reason we don't know it beforehand is because Heroku does it randomly. It chooses the port which it feels is the most relevant for it, depending on their load and such. All right, with that, you would have noticed that I did not have to write a package of any sort. I did not enforce any amount of significant boilerplate or even any kinds of rigidity in terms of what I can specify or not. So it's a simple script which we're going to try and productionize next. Yeah, you want to select apps, which are where are mini batches. The mini batches are inside the train script. If you would go along to the train script, you would find where we actually break down all of the the image sets, and we create the make mini batch function in the train set. Which are the best GPUs? So any GPUs that you have on hand are almost always better than no GPUs, but one kind that we work with very frequently is a standard across the domain is something like a V100. Flux works well with the CUDA stack, the NVIDIA CUDA stack, and also there are implementations available for AMD GPUs, obviously. Can I use PyTorch or TensorFlow there with Flux and backpropagate? That's a really, really interesting question. Yes and no. So there's a package called torch.jl inside the FluxML organization, which does allow you to, in fact, use torch kernels inside Flux. And even to backpropagate, that's completely doable. If you want to use those layers directly, there are packages, again, torch.jl or tensorflow.jl, which do allow you to create models very akin to the ones that you will find in Torch or TensorFlow. But fact of the matter is that there is enough work gone into Flux for the APIs to be stable enough so that you can actually translate those models fairly trivially. All right, let me, can folks see my terminal? Cool. So we just saw our scripts over there, right? And this is essentially that same repo. And in here, we see that we have our proc file, our environment files, some random assets that we would want, the training script, which we don't really need, and the actual Dash model itself. All right, so the question is that a BSON file will have the trained model, that's right. How do you create a BSON file? And for that, let me point you back to the Flux docs. This is where you can find how to save and load all of your trained models via BSON. All right. So now that we have our plain old directory and Git repo with all the different things that we're interested in, all we really have to do once we download the CLI, the Heroku CLI, we can do Heroku login. That should take us straight to the browser in order to authenticate that we have in fact done due diligence in order to make sure that we can actually log into the CLI via uh, via our terminal. And cool. It seems like I'm logged in. Right. That's neat. The next stage that we are interested in is actually making sure that in making sure that we can create our Heroku app. So let me just copy this this bit of incantation right here. So you would notice it calls Heroku create the app name. We can give an app name, and it uses a build pack. So what is a build pack? A build pack is basically a script or a bunch of scripts which are run prior to our model actually being deployed. So this is where we would actually go and do things like download dependencies, set any flags that we may need, um, and we take good use of it in our system. Where let me go to the repo that is mentioned here, the Heroku build pack Julia. And I want to point out what I'm doing here. So I'm going to be, is this is not the one that I wanted. Quickly move to the one that I care about. Sorry for that. Right. So this is what I want to talk about, right? So what we're doing here is we're taking our environment files, so the project and the manifest. We're taking all the all the packages that we use in there, and we compile them using package compiler into a single sys image, which means that we can basically remove the latency of first call after the pre-compilation. So package compiler will take care of all the initial steps for us. And once we deploy our models, we should be able to see fairly performant, fairly performant production capabilities. So as you can see, Heroku created the app for us. It names it by itself. If you don't, so I don't have a Heroku app name suggested here, but if you do, it will take that for sure. But as of now, it says intent sure and some number. So let me go over to So this is where I spoke about package compiler taking care of creating the custom sys image for us. So let me go to my Heroku instance, the account, and I should see, there it is, intent sure. And this is now ready for us to deploy all of our code on. So the next step that we want to take up in this case is we want to do a simple adding a remote for Heroku on our repo. And that is done simply by calling this command here, Heroku git remote, and then the name of the app. All right. The next thing we can do is quickly test that the remote is actually there, and it seems like we're all good. Next step is just to do a git init. At this point, we have reinitialized all of our important parts that we particularly care about. We can now Okay, I'll have to. I've I think committed things to this before, so we'll have to git push Heroku master. So this is very familiar to folks who are used to working with Git already, right? Um, and in this process, what we'll see is happen is all the code that we're taking up is going to be pushed to the remote that Heroku has set up, which is again just a Git client on their end. And for us, what we'll see is by just automatically, it will pick up a new version of Julia. So currently it's defaulting to Julia 141. However, in our project file, let me show that to you. In our project file, what we can basically do is in our project file right here, we can add a compact section, and in here we can say Julia equals 1.3, for example. If we so choose to run our app on uh, a specific version of Julia. Suffice to say, however, that that is not always necessary, considering that minor changes aren't usually breaking, which means that you can sometimes just get away with a new version of Julia, especially if it gives you better performance to boot. All right, so this little part takes a little bit of time. In the meanwhile, what we can do is we can go over to our overview and look at the activity that's going on. And as you would notice, that there is in fact a build in progress, and the build in progress is the same one as we see here. And all the logs that you see here are replicated exactly here as well. So you would notice that it is currently at the stage where it is pre-compiling and creating the system image for us. This can usually take a few minutes, and in the meanwhile, I would encourage some questions if folks have at this stage, and then we can go over and look at what our finished product basically looks like. So feel free to either unmute yourself or talk in the chat. I'm monitoring the chat as well. Another thing that folks wanted to talk about in earlier was using physics informed networks and usage with SciML. Now that's a really interesting and upcoming piece of area of research and progress, where people are able to use existing domain knowledge within their training models, and that involves significantly speeding up a lot of very complicated learning routines. So what I had there was a simple editor, a simple Sublime editor, and the things that I wrote in the shell, as I mentioned, those commands basically just create an app, initialize a repository, and push to a remote. That's all there is to it. I do use Atom for certain tasks. In this case, however, this was just an editor because that's all we really needed. And the explanation is actually inside the code. If you actually go to the code, there is a fair amount of documentation. Further documentation, if you want, I would encourage you to go to both the Flux docs as well as Julia docs and see what kinds of things that you're looking for. Is this project management in Julia similar to virtual env? Um, yeah, so it is kind of similar like virtual environments in Python. What is different is, however, you can actually port them to Julia versions up and down the scale as well. What I mean by that is simply that apart from some breaking changes, for example, in 1.3, we introduced this concept of artifacts, which made manifest files made post 1.3 incompatible with the ones before that. Apart from that, this idea is that you want to create an exact copy of your environment at any given point in time, so that moving forward, all you really have to do is call this command called an instantiate, which will download the exact versions down to the commit values, commit chars that you want. And that way you can basically ensure that whenever you deploy your models in environments or in deployment centers which are completely new, you can get up and running really quickly. So for example, you would notice that in here I have had to do no further, mucking about getting any environment set up. The only really different thing that I had to do to work with Heroku was that I had to add the proc file, which was just a single line. So what does train do? Train.jl basically has the code that you use to actually train the models, right? So that's separate because we don't really need to train the models any time, you don't really have to train the models every time, right? So you have one trained model and then you can share those weights across all the kinds of areas that you want to send it in. Another really cool feature which I was actually reminded of was that the code base for the GPU and the CPU versions is identical. There is no real changes, and even when there are very few to negligible ones, which allow us to basically share our code within environments which are very, very difficult otherwise to actually initialize. So you would notice that when I trained my models, I did it with a call to GPU. However, when we're pushing it to Heroku, we don't really have any access to GPUs without paying it. And even then, I'm not sure if Heroku does GPUs that well. What I would also recommend is this. So I did make another kinds of case for productionizing, which is where we do need access to things like GPUs, and we do want that performance, be it for a customer-facing task, user-facing task, or for higher throughput, or for demonstrations, or however, right? With more and more compute coming through, running things on the GPUs is significantly more important than ever before. How do I get the local environment? For that, you have to basically download the CLI, the Heroku CLI. There's a link to that on their install page. Yeah. So let me share, if you can see my screen. So I am running the exact same instance of the app on a machine that does in fact have access to a GPU. And the only real difference is that when I call my inference, I am doing so while having put my model as well as my image over to the GPU. So there you see. So this machine does in fact have access to a GPU, and in cases where that's relevant, we can basically share the same code base. We start the same project, we start the same app. There's no real difference in any of that. And what we end up with is an instance of the app that is running behind a case with a GPU. So we can think about it also as if, when you want to deploy a model which sees a significant amount of traffic, we probably want to also make sure that those cases are handled properly, which means that we could potentially club many requests together, run it through a single GPU pass, and return the results individually, which would also be significantly faster than doing it once per user. So in here, let me just refresh this app. It's a basic introduction, as I mentioned. There's not much in terms of complexity of the UI, but of course, that is something completely dependent on the user, and we can make it as expressive and as reactive, all of that stuff as we want. So I have copied over this link previously, which is just one of the examples from it. By the way, this image is just to fill up the screen to a certain amount. And after I press enter, you see this is going through a backend which is GPU enabled, and it's just giving us the image as well as the graph of where it thinks what number this is. And as you can see, it's guessed correctly, which is good. That's exactly what we want. So if I give it a 9, it predicts a 9. So the model is working well. And this way it's easy for us to communicate with the users as well as the people who end up finally implementing these things on how to do it. And as you notice, there is little to no ML knowledge required almost to productionize these things. So this is like any good chef, any good presenter. I do have one that I made earlier. So let's just take a gander at our, oh, it seems like this is up as well. So we could probably just go in here. By the way, feel free to, let me share this, this in the chat. Oops, this was, let me send it to everyone. So this is basically the link that you would want to go to. And this is where our instance is now up and running and available to everyone. So as you saw, that there are multiple ways. So like if I want something which is more geared towards a GPU-backed instance versus something that I want to be seen by a larger amount of audience by putting it in these tiny nodes all across all across the web. So there's a question. So currently it takes a little bit of time, obviously, because it's just starting up. There's a bunch of initializations that have to happen. Of course, all of those things are cost that are paid just once. So going through further, all of these things should be much faster. So the first time it's a little bit sluggish. All of that we can obviously handle on our build time, where we actually do a mock run to make sure that all of those costs are completely ameliorated. So what about deploying a DL model on the local desktop as opposed to on the web? Would Julia system be a good? Of course, yeah, absolutely. Even if you want to do it on the local system, as I showed you earlier, there is enough, enough tooling are built around that you can deploy it locally as well as on a dedicated server, a dedicated specialized server, or even a service like Heroku, or for larger grade projects, we generally recommend going to one of the, like if you don't have an on-prem cluster or service, you would probably want to go through something like an AWS or a GCP or an Azure. Right. So basically, I hope folks can go to the link and go. I don't know why it's not showing the image. That's a bit odd. Um, but in general, if if you want to go and check out the images, it should really show up as the graph that we showed earlier. So as you can see here, oh, there's some error to call back. Oh, it's just network related. Never mind. Never mind. One good thing about Dash is also that we can set up these things automatically, which is all the errors and any graph structure that we want to show. We can do that while doing our debugging. So the image link, all right. So the image link is essentially taken from Andrei Karpathy's really famous post, and it's just the images from these links from these images. Yeah. So for example, yeah, that's an example for it. Beyond that, there's a bunch of really cool use cases. So for example, this one was made by one of the core contributors to Julia to track COVID-19 cases by US counties. So there's a lot of really cool apps that are out there powered by Julia and Dash, and folks use it on a large scale at this point. So I would be happy to take some questions. I believe we're almost at the hour. So yeah, I'll be happy to take questions, answer any queries that you might have, any confusions, etc. The floor is open. One thing that I wanted to quickly address was that the way we deploy our applications is by simply pushing to the Heroku remote in our repo, which means that we can get all of our development in the same manner as we do any open source development or closed source development, which is something that people are increasingly gravitating towards to use version control managing software like Git. And Heroku is just a remote which can be called upon anytime when we want to make a new release, right? A new version, so to speak, of the application. So it's very simple, very non-invasive, and as we can see, we can share the same code base across local systems, servers, Heroku, things like that. And even when it requires using hardware like GPUs, which can be automatically translated to, which means that it's really simple to deploy the same code, the single code, in a reproducible manner to a large audience. How do I host Julia apps on Android? So there are Julia ports to on, and there are projects which run both Julia on Android as well as other ways, like the other way around, where people want to use Android apps within Julia. But for that, I would have to recommend you to read some of the discourse posts around it on how people have managed to use Julia on Android. It's a little bit out of scope for this one, I suppose. Will it be possible for folks using Julia Run to have serving capabilities? So yeah, so it's not just Julia Run. So for that, I would point you to our sales team. So you can mail sales@juliacomputing.com, and they will be best suited to to identify the kinds of needs that you might have. So if what you're using is things like a batch job, Julia Run is very capable of doing that. However, if you want to just do something like continuous delivery, this kind of a model, you might have, there's other solutions out there. And of course, all of these things interplay with each other in a manner that, you can have a very automated process where you go from a batch job to a delivered product, which is served on the web. How easily may one orchestrate microservices with Julia, Python, etc.? So one way to imagine microservices architectures is something very similar to what we've done here, right? So this can act as just one backend. So it doesn't even need to have a UI. This is largely just for the purposes of our demonstration here. And of course, that means that we can spin up instances where and however many as we want. So that whenever people are working on large domain problems, it's actually possible that you can share the code and make it highly available. Are there any issues with interoperability? Not really. Really, you probably want to describe your use case a bit more clearly for that. But yeah, I mean, if I could get an understanding of the use cases, I could probably guide you in a better position. But there are no real challenges with interoperability, especially with Julia and Python. So Julia has this fantastic system called PyCall. So in this, you can directly call Python functions, and it is in fact the Python objects that are returned to you, which also means that in many ways, all of the Python ecosystem is available to you. Yeah. And Julia interoperability is one of the more interesting parts of Julia. So you can call many languages from Julia. Is it developed enough now that it's possible to do whatever we might do in PyTorch and Flux? Yeah, I would suppose so. As a developer, maybe I'm a little bit biased, but at the same time, I can say for sure that all the functionality that is available in PyTorch is also available in Flux, albeit in slightly different APIs. For example, we don't have all the utility functions necessarily, but we definitely, that's purely because we can already pre-use a lot of the utilities that Julia already provides us. So for example, for lazy operations, they have their own entire stack. For sparse operations, they have their own entire stack. We can reuse the same thing from Julia and preserve our performance. Still remain just as fast. I saw you implemented Mask or CNN. Yeah, I did. The development is still active. Can we use train custom model? It is as fast as the one in Python. I probably will need to benchmark it properly though. The development, it should work. There is no reason for it to not, because we don't really make that many breaking changes. But can we use Flux to train custom models? Absolutely. I would highly recommend you go through some of the models that we have developed, say for example in Metalhead.jl, which is some very classic image classification problems like ResNet and BGG and Inception. And in there you can go along and see how those individual layers are constructed, and you'll find that it's doing the same exact thing as you would in the paper, right? Which means that it's fairly trivial to train custom models. I would also recommend going through the custom training loop in Flux. And in here, there's also information about, it's just a for loop. There's nothing special about it in Julia, which means that we can actually make it, right. We can actually make it work with custom training routines, custom optimizers, control flow recursion, any kinds of familiarization that you might want. That's already available to you. Is there a way to see what's going on? Yes, you can do that through callbacks. There's multiple callbacks, but just logging systems. You can print losses. You can use TensorBoard logger example to actually have the TensorBoard interface to show the Flux model. All of those things are, all of those things are completely possible. Can we use XLA with Flux? That's an interesting question. Yes, that development is active. So if I were to go to xla.jl, something Mike Innes and, oh, not this one. Oops. Mike Innes has been working on very heavily, and recently me as well, where we try and bring the XLA, the XLA compiler over to our tools as well. Not just that, we have a lot more development going on to show that we're always at feature parity and performance parity with the other platforms as they will. It's a little bit in development stage as of now, I would say, but for sure, like if you have interesting problems, give it a go. Shout if there are issues. Otherwise, there are definitely backends that are mature enough that we can actually look at doing some interesting problems like a testnet or larger models in general using XLA and Flux. So if there are any other questions, I can hang around for a few. Otherwise, that was the demonstration that we had planned for this micro training. I hope you got to see some of the cool ways in which we can work with deploying Flux models. Um, linking the Flux models, not just in a simple, local deployment, but also say on a cloud or a more specialized environment, and how it can share the same code and still be just simple to work with. Yeah, I think I have the Mascar CNN somewhere. Oh, that was easy. Is there any example of Flux native transformers? Yes, I would recommend you check out transformers.jl. I spelled it wrong, but transformers.jl is where you can get a lot of the transformers, pre-trained transformers even available to you. This is completely written in Flux, in complete pure Julia. So that's always helpful. So if you want to hack around, it's completely capable of higher levels of complexity. If you want to mix and match with existing tooling, that's also something that we want people to encourage and use as much as anything else. If I want to learn Flux, or should I focus on the Model Zoo plus Flux plus Julia Academy stuff? So a lot of Flux, as I have alluded to before, is very simple, and it's simple in the sense that we make it a point to not introduce too much complexity in areas that don't need to be very complex, right? Which doesn't mean that we give up on performance, but we make sure that we do things in a manner that can be generic enough to be implemented in a larger domain problem. For example, with Zygote, one of the goals was to differentiate arbitrary code, not just APIs that we have blessed, for example. I would recommend going through some of the trainings in the Model Zoo and the documentation. That's a very good starting point, especially if you want to learn the higher level syntax, which is always the first step in order to understand the complete capabilities of a framework. And of course, the code is always open, and we're more than happy to take over any issues and peers and such as you might have. Yeah. All right then. This was a really fun talk. Hope you guys learned something from this. I had fun, and hope to see all the cool stuff that you guys might put forth using these really cool tools in the future. Thank you. Right.